These are solutions to Melham's Calculus 2 at City College, Math 110B, exam number 3. And question number 1, y equals the square root of 25 minus x squared, or 25 minus x squared to the 1/2. And we're told that we're going from 0 to 5. Okay. This is part of the circle x squared plus y squared equals 25. And we're told to integrate from 0 to 5. So that is 1/4 of the circle. Okay. So the arc length should be 1/4 of the circumference, 1/4 of 2 pi r. That comes out to be 5 pi over 2. So that's what we're expecting. So I've answered the second part of the question first, that it should be 5 pi over 2. Y prime is 1/2, 25 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. That 2 cancels that 2, so I have negative x over radical 25 minus x squared. So that's dy dx. If I square it, I get x squared over 25 minus x squared. By formula, I add 1. I add 1 in the form of 25 minus x squared over 25 minus x squared plus x squared over 25 minus x squared. Add them up, x squared cancels out. I have 25 over 25 minus x squared. I will divide the top and bottom in red by 25. So it looks like 1 over 1 minus parentheses x over 5 squared. All right, so that's what goes underneath the radical for the arc length formula. So L arc length is integral from 0 to 5 of radical 1 over 1 minus x minus 5 squared dx. Do u substitution. U equals x over 5, which is the same as 1/5 x. Du is 1/5 dx. So I need to multiply by 1/5 outside and 5 outside. When x is 0, u is 0. When x is 5, u is 1. So I now have 5 times the integral from 0 to 1 of 1 over radical 1 minus u squared du. So that's 5 times inverse sine of u from 0 to 1, which is 5 times inverse sine of 1 minus inverse sine of 0, which is 5 times inverse sine of 1 is pi over 2, inverse sine of 0 is 0. Final answer is 5 over 2, and that's 5 pi over 2, and that's what we got way back over here, 5 pi over 2. Number 2, find the arc length. Y equals 3 plus 2x to the 3/2. We're going from 0 to 1. So dy dx is 3x to the 1/2, or 3 radical x. 1 plus derivative squared is 1 plus 9x. So the arc length is the integral from 0 to 1 of radical 1 plus 9x. That's the same as 1 plus 9x to the 1/2. So integral is 1 plus 9x to the 3/2. Divided by 3/2 means times 2/3, and multiplied by 1/9 because of the chain rule from 0 to 1. This comes out to be 2 over 27. Plug in 1, 10 to the 3/2. Plug in 0, 1 to the 3/2. 1 to anything is 1. And we know how to write that, 10 radical 10. So final answer, 2 over 27 times 10 radical 10 minus 1. Number 3, surface area, y equals x cubed from 0 to 2. Revolve about the x-axis, which means you want to multiply 2 pi y times the arc length formula. So 1 plus dy dx squared, 1 plus 3x squared, or 1 plus 9x to the 4th. So area is integral from 0 to 2 of 2 pi y, here's y, radical 1 plus dy dx squared, 1 plus 9x to the 4th dx. Okay, do a u substitution. U equals 1 plus 9x to the 4th. Du is 36x cubed dx. I need a 36 inside, 1 over 36 outside. Take the 2 pi out. So 2 pi times 1 over 36 will be pi over 18. Plug in 0, u equals 1. Plug in 2, you get 9 times 2 to the 4th. That's 9 times 16, which is 144, plus the 1 is 145. So the area is pi over 18, integral from 1 to 145, radical u du. So that's pi over 18, u to the 3/2 times 2/3. Okay. 2 cancels 18, leaving me with a 9 in the bottom. So 9 times 3 is 27. So pi over 27, 145 to the 3/2, 145 radical 145, minus 1 to the 3/2, which is 1. So here's my final answer. 4, pretty much just like the quiz question before. You're supposed to get the formula for the surface area of a sphere. So y equals radical r squared minus x squared from negative r to r. Picture looks something like this. Spin it about the x-axis, we get a sphere. So dy dx is 1/2 r squared minus x squared to the negative half times negative 2x. Negative x over radical r squared minus x squared. Recurring theme, as you can tell. Square this quantity, x squared over r squared minus x squared. Add 1 in the form of r squared minus x squared over r squared minus x squared. Plus this stuff, x squared cancels out, r squared over r squared minus x squared. That goes underneath the square root. So surface area is the integral from negative r to r of 2 pi y, here's y, radical r squared over r squared minus x squared, dx. These cancel out. Square root of r squared is r. So integral from negative r to r of 2 pi r, which is 2 pi rx from negative r to r. So 2 pi r times r minus a negative r, that's going to be 2r. So 2 pi r times 2r, 4 pi r squared. Optionally, yes, you could integrate from 0 to r and multiply by 2. 5, y equals x minus 1 over x is the same as x minus x to the negative 1. You asked to show that y of 1 equals 0, so we just do it. Plug in 1, 1 minus 1 over 1 is 0, so that is done. In the differential equation part, y prime is 1 minus x to the negative 2, or 1 plus 1 over x squared. Okay, now you wanted to show xy prime plus the original y. So xy prime plus y, hopefully it comes out to be 2x. So xy prime is x times, here's y prime, 1 plus 1 over x squared, plus the original y, x minus 1 over x. So distribute x plus 1 over x plus x minus 1 over x. 1 over x cancels out. X plus x is 2x. That's what we're trying to prove. Number 6, find the values of r so that y equals e to the rx satisfies this differential equation. Right, so y equals e to the rx. Y prime is r e to the rx. Y double prime is r squared e to the rx. Remember, r is considered a constant. So we have y double prime minus 5y prime minus 6y equals 0. Y double prime is r squared e to the rx minus 5 times y prime, so r e to the rx, minus 6y e to the rx equals 0. Factor out e to the rx, r squared minus 5r minus 6. E to the rx times factoring r minus 6, r plus 1 equals 0. So r is equal to 6 or negative 1. 7 was almost just like the quiz. I think the quiz we had y minus x. This one is x minus y. So make our table. Okay, the pattern is pretty much the same. Some key points: negative 3 minus 3 is negative 6. 3 minus a negative 3 is 6. If x and y are equal along the main diagonal, then you get zeros. And it isn't too hard to see that the pattern is 0, 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1, 0, and complete the chart. Okay, so it should look something like this. There's a straight line right over here. If you're above, it should curve like this. If you're below, it curves like this. Okay, 8, Euler's method, y prime equals x plus xy. Delta x is 0.25. And you're trying to go out to 0.5, so that means you only have to do it twice. I factored into x times 1 plus y. I thought it might be a little bit easier. All right, so I'm starting at 0, 2. The slope is 0 times whatever, that's 0. So delta y is 0 times 0.25. It's still 0. So the new point is 0.252. Slope is x times 1 plus y. So 0.25 times 2 plus 1 is 3. So the slope is 0.75. Delta y is m delta x. So 0.75 times 0.25, 0.1875. Okay, so the new point is 0.5. 2 plus that, 2.1875. So our estimate of y of 0.5 is approximately 2.1875. Okay, 9. Change y prime in the original problem to dy dx, and then multiply both sides by dx. So 2y tan y dy equals 1 plus x squared dx. Y squared plus natural log absolute value of secant y equals x plus 1 third x cubed plus c. You cannot solve this for y, so you're done. Stop right there. Okay, so the integral of the tangent is ln absolute secant y. If you forget that, you can write that as sine over cosine and do a u substitution. Okay, finally 10. After you cross multiply, you have 2y dy equals 4t plus secant squared of t dt, and you have an initial condition. All right, so integrate y squared equals 2t squared plus tangent of t plus c. Square root, y is plus or minus the square root of 2t squared plus tan t plus c. Y of 0 is negative 4, so 0 goes in for t, 4 goes in over here. So negative 4, so if the left side is going to be negative 4, I don't want the positive, I want the negative. Negative square root of 0 plus 0, tangent of 0, 0, plus c. Square both sides, c is equal to 16. Plug that back in here. So the function is y equals negative square root of 2t squared plus tangent t plus 16. All right, so these are solutions to Melham's Math 110B, Calc 2, Exam 3 at City College of San Francisco.